Okay, hello, everybody. Thanks for being with us. Not so long ago, we presented Authorino, the open source cloud native authentication authorization enforcer. Following up on that introduction, today we'll be running a demo exploring some selected features of Authorino. So we will walk through 7 iterations of defining and evolving the security scheme of an API for a news agency. So by the end of the demo, we will have showcased several interesting features of Authorino, hopefully. If you are not yet very familiar with what Authorino is and what it can be used for, I totally recommend you to check out the first introductory article that we have published on this topic. It should be a 5-minute read tops, and I consider it quite useful for understanding the fundamentals of API authentication authorization. I can leave the link somewhere here in the chat. Either way, the most important bits to have fresh are the overall workflow of deploying and adding protection to a service or API, and some of the internal functioning of Authorino while enforcing such protection upon requests to that service or API, with a special highlight to what is known in Authorino as the Authorization JSON that is built by Authorino along the auth pipeline, another concept of Authorino. Okay, but in a nutshell, Authorino is a service that operates behind the Envoy proxy and that reads its state from Kubernetes custom resources. So the developers declare the desired authentication authorization scheme or define an auth config custom resource in Authorino terminology to be enforced for each protected host. So the auth config typically includes links to sources of identity that are trusted to access the service, some authorization policies that can be an implementation of an RBAC system, an access control list, or ABAC, or whatever access control model that makes sense for that protected service, right? Among other stuff related to the enforcement of those things, the verification of identity and the enforcement of authorization policies. Once an auth config is defined, consumers of that protected service who obtained an access token or any form of authentication token supported to access that service in general can send requests to the service, right, or API. In request time, Envoy intercepts the traffic, passes control to Authorino, and Authorino verifies the identity based on that provided access token, eventually fetches some additional metadata required, evaluates authorization policies, builds some custom responses, and handles control back to Envoy. Envoy will either continue with the chain of HTTP filters, ultimately redirecting the traffic to the protected upstream, or returning right away, right, to the client. Along the steps of applying that auth config on the request, a process that Authorino calls the auth pipeline, Authorino builds, and the auth config itself can refer to parts of it, a structure known as the authorization JSON, right? I'm not getting into all the details of the auth pipeline now, but this JSON starts with contextual information of the request. Then, when an identity object is resolved from whatever authentication token passed by the user, that identity object goes into the authorization JSON as well. So does any fetched external metadata. And each phase of the auth pipeline can sometimes refer to path within the authorization JSON. For instance, an authorization policy that decides based on an attribute of that identity object that was added to the JSON, or based on an attribute of a metadata object also added to the JSON, or yet maybe it's a dynamic response that configuration that gets some data within the JSON, authorization JSON, while building something to send back to the client. So those are the most important concepts to remember for our presentation today: the auth pipeline, the authorization JSON, and how the phases of the auth pipeline both add up and consume from it, okay? So now jumping right into the demo of our news agency API. So all the content of this demo is available in the form of a tutorial in this link here, which I myself will be using today. So it will take you to this GitHub repo here with all the instructions you need to reproduce yourself the demo if you want. By the end of the demo, we will have covered these features of Authorino or supported somehow by Authorino: Kubernetes authentication or Kubernetes token validation, API key-based authentication, OpenID Connect JWT verification, external metadata integration through HTTP GET or GET by POST requests, authorization based on Authorino's simple JSON pattern matching authorization policies, authorization based on Open Policy Agent policies written in Rego language, also token normalization, which is a concept usually related, but not necessarily, with festival wristbands, another feature of Authorino. Envoy, dynamic metadata, some dynamic JSON response in general, and support for rate limiting with limiter. Okay, so this is the outline of our demo. So there is a news agents API. It's a very simple API. It has no concept of authentication or authorization at all. This API basically just manages news articles. So you can create and you can read and delete news articles, okay? The API is put behind or hidden behind and the Envoy proxy to be consumed by internal clients or what's in fashion to call nowadays the west-east traffic, so traffic within the cluster, right, between services in the cluster, and also external users, so north-south traffic. Okay, so users consuming the service from outside the cluster. Everything is deployed on OpenShift. Our environment runs on OpenShift 4.8 in the cloud. However, with very minimal adaptation, the same demo could be running on native Kubernetes. The only relevant differences here are really that we are using OpenShift routes to handle north-south traffic, and some user access tokens that we'll be seeing in a minute, which might not be available exactly in the same way in Kubernetes, but all the rest is exactly the same, okay? So we could be running the same thing on Kubernetes. And we will go through 7 iterations, as I said before, of defining, of modifying, extending, if you will, the authentication authorization scheme of the news agency API to support 7 different use cases of the API. Okay, starting with sharing access to the API with teammates. So meaning that the developer of the API wants to share access to the API with other users of the same Kubernetes cluster. So say her or his teammates who also can access the same Kubernetes or OpenShift server. And applications running also inside of the same server. This is a good use case for a feature of Authorino, which is the support for authentication based on Kubernetes token, or Kubernetes authentication for sure. Then the second iteration, we will be extending access to the API to a second set of users, which will be external news writers. Those users are not users of the same cluster. They are not applications running inside the cluster, so they are external. And we will be sharing access to the API through API keys. So we'll be using API key authentication as support in Authorino. Iteration number 3, we will ensure that applications can only read and list news articles. News writers cannot delete news articles, while the teammates continue to have full access over the API. And this will be our first authorization policies, and we'll be leveraging Authorino's JSON simple pattern matching authorization policies for that. It's a use case or iteration number 4. We will open up the API to federate the users from an enterprise level, an external identity provider, an IDP, where the users can only read and list news articles at first. And they will be doing that through a single page application called the Reader's UI. Then we will be normalizing access tokens, because by the time we reach iteration number 5, we will see that we have multiple different sources of identity being accepted as trusted sources of identity or sources of users for the API. So we'll be receiving different types of access tokens in different formats. So we'll be applying some normalization of the access tokens to, among other things, allow us to simplify the authorization policies and to define some simplified RBAC control access controls, role-based access control. And together with this iteration, we will be introducing or presenting the following features of Authorino. The fastwell wristbands, we will be replacing authorization policies that we have by a simpler, smaller authorization policy written in Open Policy Agent Rego language. And because of the fastwell wristbands, you see that I will be also using OIDC to show that how the fastwell wristbands can be used also to authenticate. Iteration number 6 will be geo-fencing the API. So the idea is that we want to enforce this policy here, that non-admin users from Spain, consuming the API from Spain, cannot access the sports category of news articles. Okay, so we'll be leveraging here Authorino's HTTP external metadata integration, and again, using JSON simple pattern matching authorization. And the last iteration, we'll be adding rate limiting to the API based on the user ID. And actually, Authorino will not be the enforcer for rate limiting. It will only be generating some dynamic metadata. So limitador, which is a proper rate limiting service, can rate limit the application. So that is the idea. As for the stack that we will be deploying, I already mentioned something to you, but it starts with the news agency API, or news API for short. It's very minimal, so it has no authentication or authorization on its own. It is just a simple API that whenever a request hits it, and if it's a valid endpoint operation, it serves the request. Okay, so if it is a post to / category, it creates a news article. Okay, and creating an object here means storing in memory. Okay, so there is no persistent database for this demo. If it is a GET request to / category, it serves the list or the index of news articles in the category that are stored in memory. If it's get to /category /ID or delete category /ID, it respectively reads or deletes that corresponding news article within that category. Okay. Then we have Envoy proxy deployed as a sidecar to the news API and to serve the news API with external authorization, cores, and rate limit HTTP filters enabled, configured. We have Authorino, the authentication authorization service, limitador, the rate limiting service that we'll be using in our very last iteration of the showcase. We have a reader bot application that keeps polling for the list of news articles on different categories. Then we have the reader's UI, the single page application I mentioned before, for users to read news articles on the browser on different categories after authenticating on Keycloak. And finally, we have Keycloak, the authorization server, where we will be federating a set of the users, a subset of the users of the news API. Okay. For simplicity, we will be deploying all of the resources that I mentioned on the same Kubernetes OpenShift namespace, which is called Authorino demo. Again, this could be different. It's just for simplicity. Okay. As you can see here on my terminal, hopefully you can see my terminal now. All this stack that I've just mentioned or workload, you can see here over here on the top of my screen whenever I'm showing my terminal window. Okay. So as you can see, we already have Keycloak running in this namespace. We will not be using it until the 4th iteration of the demo. The only reason why it's deployed beforehand is because Keycloak is the component that takes the longest to be ready, so comparatively to the others. So I deployed upfront. The only component required by this demo that you cannot see here on the screen, or that you will not be able to see here on the screen, though it is also running the cluster, is Cert Manager. It is running in its own namespace. We are only watching the Authorino demo namespace here. We already had it running in this cluster, so obviously I won't be deploying it again. We use a Cert Manager to generate Authorino's TLS certificate, because Authorino serves its endpoints for the external authorization calls via gRPC, and for OpenID Connect Discovery, which is related to the support for Wristband tokens, with TLS enabled by default. So we need a Cert Manager to generate the certificates. Okay. Now,
one thing in your terminal, could you make the font bigger? That's
oh, absolutely, yeah. Sorry about that. See how big we can make them better.
Yes,
it's better. Cool. Let me move this up. This one we don't need space. Okay, good. So let me see the where were we? Okay, so the instructions. The setup instructions. I've already cloned the repo, and I've already ran this first 4 steps here, including creation of the namespace, because I deployed the Keycloak, as I said. So let's go straight to the deploying the news API. Okay, so we can copy this. Actually, I've already pasted it here. So this is creating deploying the news API to this OpenShift cluster that we have here. I'm already logged into the cluster. So basically, we create a deployment and a service for this API, and it's already running. At this point, the API is running already, okay, but it's not protected. Okay, so let's do that. Let's add some protection to the API, and let's do that by deploying Authorino, cloning latest version releases of Authorino here, and deploying it to this cluster, installing the CRDs and deploying the Authorino service to the same namespace that you see here. We should be ready in a few more seconds. And next step, I'm already copy here, will be this one. There we go. So we already have Authorino here. It's starting. So right, we can already move to the next step, which is deploying Envoy, the Envoy proxy, as a sidecar of the news API. This script here, this is basically what it does. Okay, so it will patch the news API deployment to add the second container, the sidecar with Envoy, also replace some services and routes to put the API behind Envoy to make sure that all the traffic sent to the API actually goes to Envoy, and wire things up so Envoy invokes the external authorization service, and later, oh, sorry, need to go back one step, and also the rate limit service later. Okay. So once we did that, so we're creating a config map for Envoy. I totally recommend checking this config map later, because this is actually where the whole wiring up all of the components happen. Here's the deployment of Envoy, service created, root, okay, and we also deleted the other before Envoy. Other people in the call may want to mute your mics. Thank you. And okay, so now the API is protected already, though we haven't told Authorino about it yet. So if we send any traffic to the API, Envoy will receive the traffic, the request. It will activate the external authorization service, Authorino. Authorino will look up for an auth config corresponding to that requested host. It won't find one, So it will tell Envoy to respond with a 404. And that is exactly what happens, for example, if we request for the list of news articles in the sports category. By the way, I've just stored some environment variable here because I keep constantly changing from one server to another just to simplify, okay? Oops, sorry. It's supposed to be curl. There you go. So it's a 404 because Authorino doesn't know anything about this service, right? And so let's tell Authorino about the news API then, okay? Which takes us to the first iteration of adding protection to the API. The first iteration, or use case, if you will, for adding API security to the news API comes from wanting to share access to the API with our teammates, right, and applications of our teammates running the same cluster, right, or the Kubernetes service accounts that they use to authenticate. This is a good use case for API authentication based on Kubernetes users and service account tokens. Okay, this is how an Authorino auth config custom resource looks like with a configuration for this. So we have here, it's an auth config within this API version of Authorino. The name of the resource is news API protection, and the spec we have the list of hosts that Authorino will use to look up for this specific auth config to enforce. And then we have the configuration for the identity verification phase of Authorino, right? Which in this case includes declaring two trusted sources of identities. So one that we will call teammates, right? And another one that we will be calling service accounts. Both of them are based on the Kubernetes authentication support in Authorino. Okay. The difference you see here between those two is that for the first one, we say that for every token, Kubernetes token, valid token, we should expect to have a list of so-called audiences, one of the claims of those tokens, okay? And Authorino will not only verify if a provided Kubernetes token is valid with the Kubernetes server, but it will also make sure that the proper or the expected list of audiences is part of the list of audiences of that token, okay? So for the teammates, we'll be using this audience here, which is the default audience for any token generated by Kubernetes. This is configurable, so we can change that. This is actually not a very good practice for a production environment. You want to be less permissive for production, such as when you're using in this other configuration here, where we don't list any audience here. And this is a convention in Authorino. When you don't list a specific list of audiences to be checked, Authorino assumes the host, the requested host of the service, to be the audience. Okay, so it will, whenever a teammate tries to access the API, it must do that by providing a token that includes this audience. Whereas when it's a service account trying to authenticate to the API, it must provide an access token where the list of audience includes the host name of the service that the service account tries to access. Okay, so let's deploy this. Okay, this is use case number one. So we can deploy this API protection one here that I just showed. Okay. Now, Authorino already knows about this API, the news API. We can, for example, we can repeat the last request that we made. Instead of a 404 that we get before, because Authorino didn't know about the API, now we will actually get a 401. And the reason is because we didn't provide an authentication here, right? So Authorino says 401, authorize, and it provides some challenge for the user to know how to authenticate, okay? Well, let's provide some authentication here. Let's first try to impersonate a user of the same OpenShift server, the same OpenShift cluster, okay? I don't know if you ever done that on OpenShift, but you can get a token, for example, by going to the OpenShift console. There's a way there where you can get a token, an opaque token, to access the CLI later. Or anyway, if you are already logged into the CLI, as I am, you already have that token stored in your kubeconfig file. So what I'll be doing here is just a shortcut to read from my kubeconfig that specific token that I already had, because I already used it to authenticate to the OpenShift cluster in the CLI. And I'm going to store that in this environment variable here. So it says bearer, a space, and then the token, okay? So I can use this on my request to the API, now passing a header, the HTTP authorization header, with that value. So it will be authorization, colon, bearer, space, and my OpenShift token, which is an opaque token, okay? And I will be requesting the list of news articles in the sports category. And this time it works. It's a JSON, and the JSON is an array. We have no news articles created yet in this API, so that's why we get an empty array. But it's a 200, okay? And the reason why this works, and it's interesting, because let's share this very quickly. This is how Kubernetes authentication works in Authorino. So either with the token of a teammate, which is what we just reproduced here, or with a service account token by an application that we'll be showing in a moment, what Authorino does is Authorino will, in request time, it will issue a request to the Kubernetes API to get that token review. It uses the so-called token review API of Kubernetes. And Kubernetes then returns, if that token is a valid token, that the token is valid, and some information about the identity behind that token. So it really depends on the type of the token. If it's a token of it's an OpenShift user token, you get some type of information resolved from that access token. If it's an access token, it's another type of information. But in either way, you get some information about the identity behind that token. Okay, that's why it works. It's very similar to the information you get. I don't know if you ever did this also, but at the same place in the OpenShift console that I mentioned, where you can get a token to paste here on the terminal and connect to the CLI. It also shows this endpoint of the OpenShift server, which is kind of a user introspection endpoint. I don't know if you've ever seen this, but the type of information returned here is very similar to the information that Authorino gets when it tries to verify that token. Okay, so that is the identity object that Authorino will be, in this case, be translating the token into and adding to that authorization JSON that I mentioned before. Okay, so now let's try to consume the API from inside the cluster, because we consume it from outside the cluster, impersonating a user of the OpenShift cluster. Okay, let's now consume the API from within the cluster. And to do that, we will deploy another app, which is the ReaderBot app. Okay, ReaderBot app, we create the deployment. So we will see a pod here running. And we also created a service account. So we'll be using the service, just a service that sends a request to the news API, and it carries in the authorization header, the service account token mounted by Kubelet within the container. We only made one tiny different change here. If you check this YAML file in the repo, you will see that instead of using the default service account token that Kubelet will usually mount inside of any container, we are customizing that token a little bit to make sure it includes the proper audience that we expect that Authorino will verify on request to the news API whenever it's an internal request. Okay, and also by default, the service account token is long-lived token, and we are also adding a property to make it a short-lived token. But apart from that, it's just any service account token. If you send that to the token review API, Kubernetes will validate the token and give the corresponding identity data behind that service account token, which is basically some information about the service account. Okay. So we deployed the ReaderBot. We can start following the log of the ReaderBot here, which is now polling for any news articles in these categories here: sports, business, economy, society, entertainment, tech. Okay. So now we can try to create a news article here. So let's use again. Is that? Oh no, sorry. This one, right? Yes. So here, the authentication token is the one from the teammate. Teammates can create news articles. So we'll be issuing a post request to /text. We'll be creating a news article in the tag category with this title and this body. So this is the payload, okay? And we got the news article created here. And the reader bot polling inside the cluster already got that news article that we just created. Okay, authenticating using the service account token. And this settles for use case number one. We already have teammates able to access the cluster, and we already have applications within the cluster, only with that tiny auth config that I mentioned before. Let's move to iteration number two here. So iteration number two, we want to extend access to the API with those external news writers. So they are not teammates, they are not applications. And we will be doing that by allowing them to authenticate using an API key. So in Authorino, the way we define API keys is by creating a Kubernetes secret. And as long as the secret has among the labels, the same label selectors we identify here in the auth config custom resource, Authorino will reconcile that and we will identify that as a valid API key to access this API. The only extra bit of configuration that we are adding here, didn't have to, but we are, is that in this case, instead of passing an API key in the authorization header as bearer and the value of the API key, the key selector will be API key. So it will be authorization header, API key, and then value of the API key. Okay? So let's deploy API protection 2, this YAML that I just showed. Again, we are not removing anything from the previous use case, okay? So we are extending the previous one. So basically, we are applying something the Authorino will reconcile, will identify, it will update its internal cache. Now it gets a new configuration for the news API, new auth config for the news API. We created that, and we also created together inside of the same YAML, inside of the same manifest, a secret that represents an API key. So now we can use that API key. I'll be changing here my authentication environment variable to API key, and I will be getting that secret, the value of the API key data of that secret that we created together in that YAML file. Okay? So now, if I send a request, for example, to create another news article, this time in the society category, we will be authenticating through API key. Okay, so it's another post request, different payload here. And the external news writer can create an API, can create a news article in the news API, as you can see. And also the reader bot here already caught that here, and it's showing in its logs. Okay? And again, so this small schematics of how this works. So the secret created is reconciled by Authorino as a valid API key. So when you send a request, Authorino already knows about that API key and can therefore authenticate it. Okay. Iteration number 3. Now we want to ensure that service accounts can only read and list news articles. External writers cannot delete them, while the teammates continue to have full access to the news API. Okay, so we'll be introducing our very first authorization policies here. So far, we only had identity verification rules or some authentication policies here as well. We'll be adding 2 authorization policies here using Authorino's JSON pattern matching authorization. Okay, so the first one is service accounts can only read. This is a JSON. JSON is in reference to this type of authorization policy of Authorino. The way to read this is if the conditions match, then Authorino will enforce the rules. Otherwise, you can just skip this this authorization policy. You can ignore this authorization policy. So in this case, remember, when a user sends a request, the first phase of Authorino is try to verify the identity. Verifying the identity means if it's successful, translating whatever token access token provided into a identity object, right? That identity object, as I said before, goes into the authorization JSON. So with this type of authorization policy here, we can navigate inside of that JSON, get some information within that JSON, and we can write some rule that use that information. Okay, so this is what we're doing here. So if in this path auth.identity, so and here comes the identity object. If the identity object has a JSON property called ISS, it stands for issuer, equals to this value here, so we know this is a service account. And the reason why we know this is because we are using either service account tokens or OpenShift user tokens. The OpenShift user tokens, they translate to identity objects that do not include the ISS claim, and we know that by experience, right? And external writers, which are API keys. And the API keys, the corresponding identity objects, are the Kubernetes secrets that represents the API key. So the only identity objects that include so far this ISS property are the ones coming from this identity source here. So we know for a fact that if this condition matches, it's because the authentication method used was a service account token. Okay? And the rule is now fetching again from within the authorization JSON, but from a different path. Okay, context information dot request dot ATP dot method equals get, meaning it must be a get. If it's not a get, then access shall be denied. Okay, so if this condition applies, then it tries to enforce this rule. This is the first authorization policy. The second one is external writers cannot delete. It's similar. So if in the identity object you have a kind property, and that kind property equals secret, which is the case only of the subset of users authenticating through API key, obviously for this auth config, then Authorino tries to enforce this rule here, which is, again, the method must be not equal to delete. If it's delete, access shall be denied. Okay, this is iteration number 3. This is how we model those two authorization policies that we want to enforce here. The service accounts can only read, and the external writers cannot delete. As you can see, we don't need an authorization policy for something that is already given by default, right? So there's nothing forbidding or blocking access to teammates. So they will continue to have full access. Okay, only so it's clear here, this part of the configuration for the authorization JSON policies, they are references, their path within the authorization JSON. Okay, so let's apply use case number 3. And copy this as well. Well, unfortunately, we don't have any application running in this same namespace that could be trying to access the news API other than to read news article. But hopefully, I can convince you that our authorization policies work by trying to delete a news article authenticating with API key, right? So last time we used the authentication with API key to create a news article in the society category, right? So we succeeded doing that. So we got an ID for the news article here. Now I'm trying to delete this news article. And it's forbidden because the news writers cannot delete, right? So the policy was properly enforced. Okay, moving on, iteration number 4, we will open up the API to users from an IDP, from an identity provider, an auth server. And for now, those users will be able only to read, right? We will be using Keycloak as our IDP here. So we have a set of users that are Kubernetes users or users of the same OpenShift cluster. We have applications running in the cluster. We have API keys, so external writers. And now we will also have any users within a given realm created inside of Keycloak, right? And for that, we will be using support for OIDC JWT verification in Authorino. So all it takes is adding the endpoint of the issuer here. So we will be adding the endpoint of Keycloak, the Keycloak realm, where the user will be federated. And since we also have an authorization policy here that those users can only read for now, we also need to add another policy, authorization policy here, which is similar to the other ones that you've seen before, okay, from the previous iteration. So here, IDP users can only read. The condition is now we also can trust on the existence of the ISS claim, because Keycloak includes on every ID token, every JWT issued by Keycloak, this claim, and the issue will be pretty much the same issue that we have here, right? So if this condition matches, it means that the user used a Keycloak issued access token to authenticate to the news API. And then we also try to enforce this rule. Okay. So use case number 4. Oh, by the way, let's do this. I didn't finish this from the previous one, but if you want to, this is cool. We failed to delete last time, right? But teammates can still delete, right? So if we get again the token from the teammate, and we try to repeat that delete request, the teammate can delete the news order. Okay. So yeah, use case number 4. I already deployed Keycloak, so we can skip this step here. It's already running. The only thing we'll be doing other than deploying Keycloak here before actually enforcing the auth config is that we will be patching the Authorino deployment so it trusts the Keycloak certificate, because we deployed Authorino after, and we didn't add the Keycloak certificate to the chain of trust certificates in Authorino. And since Keycloak uses in this deployment a self-signed certificate, we need to do that to avoid any TLS-related errors. So, but this is pretty much everything that I'm doing. Okay, so just creating a config map with the Keycloak CA certificate, and we're making sure that this certificate is part of the chain of certificates in Authorino. Okay, but this is it. We will also deploy the reader's UI, so the single-page application that users will be using to read news articles after authenticating with the Keycloak realm. Okay. What else? We need to create the Keycloak realm, because we only had Keycloak running, nothing else, only with the master realm. We need to create also a Keycloak client for the reader's UI, so they can exchange credentials in a no-auth flow. And they are running, okay? So now we only need to apply this auth config that I showed before, okay, for iteration number 4. And there we go. So we created auth config. That is the secret from the API key before. And we also created a Keycloak user named John here, okay? Now, if we go to the browser and we try to load, oops, excuse me, this one. Yeah. This is the reader's UI, okay? So right now we are not logged in with any user. So if these buttons here, basically they issue a AJAX request to the news API and try to fetch the list of articles news within this category, okay? So if we try to use any of those, it will return 401 because we don't have any token yet. We need to get a token, okay? So let's log in. So if we click login, the reader's UI redirects to this Keycloak provided login page. We can log in as John, which is the user we created. The reader's UI will exchange, the authorization code for an access token, a Keycloak issued access token. It will store this here. So the AJAX request to the news API will be authenticating using John's access token. Okay. So now, if we send request to the news API, we get some responses. The only news article we have is the one that we created in the tech category, because we deleted the one in the society category, right? But as you can see, it works, right? So you can authenticate using John access token. Okay. Now we are already, there are some details here as well for how this works. I guess the most important part is that when we apply the auth config for iteration number 4, and we therefore also introduce KeyCloak as a valid source of users, Authorino exchanged with KeyCloak the required JSON Web Key set to verify and validate ID tokens for KeyCloak. So it does that in reconcile time. So in request time, Authorino can verify and validate the ID tokens without having to contact with KeyCloak again. Okay. Now we are heading to the end of our demo here, and an iteration. So because of that, iteration number 4, I want to push a little harder and introduce at once a couple features of Authorino. So here we will be introducing token normalization, also the festival wristbands, even though I won't be getting too much into the details of those. Open policy agent authorization, and because of the festival wristbands, OIDC token authentication again. Okay, so this is the use case for adding token normalization, and at the same time, some role-based access control, or simplified role-based access control. Until iteration number 4, I mean, even now. So we are accepting requests. We are trusting multiple different sources of users here to access the news API. Okay, as I said before, each source of user issues a different type of token, and therefore the corresponding identity object that we resolve from that token differs as well from identity source to identity source. Okay, so token normalization consists basically on trying to normalize that, try to make sure that after you verify the identity, regardless of the source of that identity, you can trust that you have a token with the same set or subset of information that you'll be using in the next in the consecutive phases of the auth pipeline. For example, that allows you to simplify some authorization policy that you write, or as I will be showing here as well, in case you want to issue a token, another token, exchange the first token for another token issued by Authorino, which is the concept of festival wristbands. You can also do that in a simpler way. So very quickly here, okay? We'll be using these extended properties of the identity objects. This is basically what it does is, after Authorino resolves an identity or verifies an identity from that source whose access token was issued by that source of identity, so we already have an identity object. Authorino, before appending that identity object to the authorization JSON, it extends that identity object with some custom properties that we define here, right? So when it's a OpenShift user token, which is the case for the teammate, we don't have the sub claim inside of the information provided by Kubernetes when it validates OpenShift tokens. But we have a user ID. So what we're doing here is we are using the same information already available inside of the identity object in the form of a UID property, and we are adding another property. We are extending the identity object with another property called SUB, standing for subject, right? So basically, we are renaming the UID property as sub inside of any identity of the identity objects that we resolve whenever the user authenticated using this source of identities here. Okay, and similarly, we are getting this information from the OpenShift provided user information username as name within the identity object. And we are also defining a static a property inside of the identity object called rows, which is an array, which in this case only has only one element, which is the admin string. Okay. Similarly, for the service account tokens, the corresponding objects, in this case, we don't need to create a sub property because the service account tokens issued by Kubernetes already include a sub claim inside of it, so you can trust that one to identify the user. but we don't have a name. But we have a service account.name, so we can use that and call it name inside of the identity object. And again, another one called rows, which is an array only with reader. For the external writers, we are using the name of the Kubernetes secret that represents the API key used to authenticate. We're calling that sub. When we create that secret, I didn't show before, but we also made sure to include an annotation in the secret, in the Kubernetes secret. The annotation is news agency / author name. It contains the name of the news writer, okay? The author of the news article. And we can use that annotation, fetch that annotation, and we can call that name inside of the identity object. And the news writers, they will have two roles, reader and writer. As for the KeyCloak users, we don't need sub, because KeyCloak already injects that inside of the ID token. We don't need name, because KeyCloak already includes the name of the user. And the roles, we do have the roles already inside of the KeyCloak issued ID token, but it's inside of realm access rows. So we can move that to just rows. And by doing that, after the identity verification phase of Authorino, we can trust that whatever comes next, being fetching some metadata or some authorization policies, all those phases can trust that the identity object always has this same path inside of it. So you can always access identity.sub.name.rows. And that allows us to simplify those authorization policies that we had before that had to take into account the differences in the formats of the tokens. So for this role-based access control policy here, we will get rid of all the other authorization policies we had. This is the first time we're actually deleting something from the auth config and replacing all that with only this authorization policy here based on Open Policy Agent. Right? So this is Rego language and quite straightforward, easy to understand. So we are getting from the identity object the list of rows, from the context information the method, the HTTP method, right? And these are the rules. These are the only conditions, the only cases where access should be granted to the API. If the method is get and the list of rows include a reader role. If the method is post and the list of rows include a writer role. Or if the list of rows include an admin role. In this case, we don't care about the method, okay? And this basically replaced the same authorization policy we had before for a simple RBAC system that now can be written using the already normalized token, okay? As I said, I won't get too much into the details, but in this same iteration, we are adding wristband tokens. Wristband tokens are OIDC tokens, OIDC compliant tokens that Authorino can issue after it already granted access to an API. So after the authorization step, Authorino can be configured to generate another OIDC token and supply that in the response, provide that within the response. The typical use case for the wristband tokens are for the implementation of the so-called edge authentication architecture. So when you have one auth config where you accept multiple sources of identity and you exchange all of those for one wristband token, and that lies on the edge of your network. And then you have multiple other services, microservices, if you will, that only accept the wristband token as a valid source of identity. So the user first authenticating the edge using whatever authentication method supported, get a wristband token, and then start sending requests within the network, now authenticating with the wristband token. Right? So typically, issuing a wristband token happens in one auth config, accepting the wristband token as a valid source of identity happens on another one. I only made sure to include both of them here, only so you know how they can be used. But typically, they won't be using the same auth config, although you can. Right? In this case, you can authenticate using any of the accepted authentication methods. It will get you a wristband issued, and then you can send another request or all consecutive requests using the wristband token. Okay? And the configuration for the wristband token is a JWT, okay? It has claims, and the custom claims will make sure to include all the same claims that we added in the normalization step for the other identity source, sub, name, and rows, okay? So we are already running out of time, but hopefully we can demonstrate this quickly here. Create this here. if we, let's say we get the list, what are we doing here? No, sorry. Yeah, I already did this. So got the API key. If we get the list of news articles, as you can see, it will issue a wristband token. We could later send another request authenticating with the wristband token, and it will work. Okay. Moving on very quickly here. Iteration number 6, we want to geo-fence the API. Okay, so we want to make sure that sports news or news articles in the sports category cannot be accessed by non-admin users if they are based in Spain. Okay, so to do that, we'll be using this other feature of Authorino, which allows you to fetch some external metadata from an external source. So in this case, what we'll be doing is we'll be exchanging the remote address of the user, the IP of the user for some geolocation data using this open API here. So this is the configuration for the metadata request. So we can use here also some dynamic data fetched from the authorization JSON. So this is the exported for HTTP header passed by OpenShift AG proxy to Envoy passed along to Authorino, so it's available in the context information of the request. We issued a request to this endpoint here, which translates to some geolocation metadata, allowing us to write an authorization policy for that. So this, again, we could use JSON authorization here. So if the list of rows, because we already normalized the access tokens, we can trust that we always have this property here. If the list of rows excludes admin, meaning if admin is not present there, and the path of the requested path matches this regex here, so it starts with /sports, then the country must be not equal to Spain, cannot be Spain. Otherwise, access will be denied. Okay, so if we apply this, and we also created another Keycloak user here called Jane. And if we go again to the news API, sorry, I need to log in again. The news API, John can read news articles except from the sport. This is because I am myself based in Spain. So my remote address is recognized as a Spanish remote address. So basically, I'm impersonating John from Spain, okay? But that's not the case for Jane, which is another user, because Jane has the admin role, right? So if we log in here as Jane, even though we are still based in Spain, Jane can access the sports news articles. Okay. Only so we don't miss anything. Last iteration is we want to enforce some authenticated rate limiting. We'll be using limitador for that. Okay. But limitador needs some information from, of course, the authentication from the authorization service to be able to scope the limits. And limitador is configured to scope the limits by user ID. In this deployment of ours here, so we are deploying limitador to the namespace, configuring to limit requests to 5 requests per minute per user. So we need to provide some user ID information to limitador. So the way this works is by using this other type of dynamic response in Authorino. First one was the Wristband that I mentioned before. This other one is where we wrap dynamic response, dynamic JSON as Envoy dynamic metadata. This is a feature of Envoy, actually. So Authorino will provide some information back to Envoy, and Envoy will inject that into the next HTTP filter in the chain, which is limitador in this case. So what we are doing here, we are creating a JSON to Envoy, which has only one property, user ID, and the value of that property comes from identity object.sub. So basically, we are using the subject within the identity object as the user ID. Okay, and if we apply this auth config here, and we go again to the reader UI, 1, 2, 3, 4, 5. Starting from the 6th request, we start getting some 4 to 9 too many requests. Okay? And this is with Jane. Of course, if we change a different user, then we have another 5 requests that we can send. And something that I didn't mention, but it's just interesting, it's mentioned here. In the previous iteration, if you use Tor browser, of course, that would be a way to work around our gel fence, of course, because usually Tor browser would give you a remote address that differs in location from the one that you actually are. So that would be a way for John to be able to access the sports news articles. Anyway, I hope that has been interesting. And if you need any more information, I recommend you go into the GitHub repo of Authorino or to the Quadrant organization in GitHub. And thank you very much.